everybody. I got a couple questions here that I'm going to do just to additionally kind of demonstrate some of the course concepts from this week. So I just kind of made this up here. Let's say Facebook analyzes its salaries for software engineers as part of their annual review to ensure that it's competitive with other companies. So the salaries in hundreds of thousands of dollars are as follows. Now, it's important to note in this question that these are already in order. I've noticed that I'm going to be asking for the median as well as the mean and the standard deviation. So for the median, it's important they are in order, and they are in hundreds of thousands of dollars. So you got to multiply each one by 100,000 to get the actual salary. But we're going to keep these numbers as is because that's how they're presented. So for the mean, we already know that we are just going to be adding every single one up and then dividing by the number that we have. So 1, 2, 3, 4, 5, 6, 7, 8. So you can go ahead and write that there's 8 numbers here, and you are literally just going to show your work like this. So you go 90 plus 95 plus 105, and so on and so forth until you get to the end. Okay, and this will all be divided by 8. That is the world's most crooked line. So just showing a bit of my work. I'm going to add these up here. And it looks like I get a sum of 940. And now that's going to be divided by 8. So let's see what we get here. We get a 117.5. So now that I'm on my final step, it is important to add in the dollar sign. So that would be 117,500 if they were asking, but you can just leave it like that. Oh, there's the mean. Let's take a look at the median. Now remember, for median, the first step would be to organize the numbers least to greatest. Now that's been done for us, so we don't need to worry about that. The formula for median is simply, it's like asking Q2. Right, it's the same thing as asking for the second quartile. So the median is the halfway point. So you go 1/2 times how many data points are there? Well, there's 8. So that's going to indicate that it is the 4th position. Now you need to remember from our notes, if you have an even number of data points, your median is going to be the average of the middle too. So when I do my formula to figure out what position I'm at, I need to remember that when I go and count up to the 4th one, this isn't actually the median. I only have 3 to the left and 4 data points to the right. So that's not actually the true center. The true center would be adding up these two. So for the median, we can go ahead and go 115 plus 125, and then you're going to divide it by 2. Might have to scroll down here to touch. So divide by 2, and you get that the median is equal to, looks like 120, or 120,000. There we go. Perfect. So the median is 120, or 120,000. So for standard deviation, I'm just going to remind you that we have a particular formula that we use for standard deviation. This is a sample standard deviation, and you're going to have to, figure that out based on the fact that, this is a sample from Facebook. So it's obviously not going to be a population question. Most of the times when we're doing a question, we are dealing with samples after all. So the formula from our formula sheet for standard deviation is this one. Now, the reason why it matters if it's a sample or the population is because for a sample, we go n minus 1 instead of just n. Now, we have 8 data points here, and the way you show me your work is sort of up to you. You can make a table. You can make a nice little table where you go xi minus x bar squared, and then you have the work, or you can just throw the work down on the page. So what I'm going to do is, remember that standard deviation is just the variance squared. So it's going to be just kind of tricky for me to do a big, well, I'm going to try actually do a big square root symbol. And it's going to have to be very big. There we go. No marks for being sort of crooked. So here we go. We're going to go 90, which is the first data point, minus the mean. And then that's squared. So that's what your work could look like. Plus 95 minus the mean squared, and so on and so forth until you get to the last one. So I don't know if I'm going to run out of room, but I am going to do my best. The next one is 115 minus the mean squared plus. Reason a table might be sort of nice is you don't run the risk of running out of room as easily, I don't think, because you kind of have it in a column. Now this 125 one happens twice. So, right, there's 2 data points, so don't let this confuse you, but I'm just going to multiply this by 2. So I'm going to put a 2 in front of here. There's 2 of these, so 2 times whatever answer I get here, plus 135 minus 117.5 squared. And I'm going to have to use my mouse. My writing pad has limits, and apparently I've reached the limit. All right. And I can extend my very ugly square root sign. And all of this, of course, is going to be divided by n minus 1. So 8 minus 1. So, yeah, it's kind of scary looking. Let's do a couple spot calculations here. I'm not going to do every single one, but just as an example, if I do the first one here, on my calculator, I go 90 minus 117.5, and then I'm going to square that number. So for example, for that one, I got 756.56. So 756, oh sorry, 0.25, I misspoke. 756.25. That's what I got from that one bracket there, okay? So what you could do is, on the next step is you could write that. So you could write, your big square root sign, and you'll need a little bit less room. And you can go, okay, so I got 756.25. I'll do the next one as well. Plus, so it's 95, subtract 117.5, and we're going to square it. That one gives us 506.25. Okay, so what I'm going to do is I'm just going to go plus dot 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 until you get to the end, and then you're going to divide that all by 8 minus 1, which is 7. So figure those all out, and what I'm going to do is I'm going to give you the final total before we do the actual division here. So if you just give me a moment, I will throw that total down. Okay, so when you do that, you get a nice number somehow, 2,900. And I'm going to divide that by 7 and then do the square root of that number. So when that's all done, I get that the standard deviation is equal to 20.354. Now, there's no indication as to what to round to, so again, we'll talk about that in the future. Don't forget the dollar sign, that does matter. All right, next question. So, same numbers, just different question. Part B is find the third quartile, and then find the 59th percentile. So for Q3, what we're going to want to do is just remember the formula is, whatever fraction you're looking for. So Q3 is 3/4 of the way, right? And then it's times n. And that gives you the position. It doesn't give you the actual number necessarily, it just gives you the position. So for Q3, what we're going to be looking for is 3/4 times, how many are there? There's 8. So it is the 6th position. Now, something to keep in mind is that if you have exactly an integer, our textbook stipulates that you need to add the 6th and the 7th position when you get exactly an integer. Had I gotten the 5/5.75th, position, then I would just round up to 6 and call it a day. But because I got exactly an integer, then we need to also add in the 7th. So I'm not sure if that's something that was super clear in the notes, but I'm trying to make it more clear now. If you get exactly an integer, you need to do the average of that position and the next one, whether it's a quartile or a percentile, whatever. I think we'll see in the next example, maybe an example that has a decimal. So 1, 2, 3, 4, 5, 6. So there's the 6th one. Because we got exactly 6, then we're also going to add the next one on. So our Q3 calculation is going to look like this. We're going to go 125 plus 135, and we're going to divide it by 2. And that's going to give us 130. Perfect. Now, let's take a look at the 59th percentile. So very, very similar formula. You're going to write, generally what we write is P for percentile, and then 59 is generally understood to be the 59th percentile. So whatever percentile you're looking for can go down there as a small number. And percentile means out of 100. So you're going to go 59 out of 100, and then times 8. So a percentile is just, it's like a quartile, except it's not one of the quarters, but the formula is identical. And the rules we follow are also identical. So I'm just typing that in on my calculator, and I get 4.72. Now remember, that's the position, so I like to write that. 4.72th position. So what does that mean for us? If we get exactly an integer, then we have to average that position and the next one. If we get a decimal, what we do is we round up. So we say, well, this is going to be the 5th position. And we go count it up as long as they're in order, from least to greatest, 1, 2, 3, 4, 5. So the 59th percentile is 125. There you have it. Perfect. Next question. We are rolling along. So find the z-score for a salary of 110. I wanted to make sure to review this because we sort of introduced this concept in this chapter, and then it doesn't really come back for a couple of weeks just yet. So we know from our notes that the z-score formula is this one right here. It's also on the formula sheet. Now, obviously, these are the symbols for the population. If you're doing a sample and you don't have those, then you're going to substitute in the numbers we do have. So we don't have the population mean, but we do have x bar, which is the sample mean, and that's the one we're going to use. So there's that one there. And then we also had the standard deviation that we calculated before, and we got 20.354. All right. So I'm going to just switch colors here. I'm just not feeling the red right now. So z-score for a salary of 110. Well, that's what this x is. Okay, so that's the x in this formula. So we can go ahead. We can plug in all the numbers. We can go 110 subtract 117.5 divided by 20.354. And you can type that in on our calculator. I have a very noisy calculator. We get negative 0.37, and I am rounding there to 2 decimals. When you're doing a z-score, this will be more important later, but just round to 2 decimals. When we start looking at the z-score tables, it's going to be obvious why. Our tables only go to 2 decimals, so that's why. It's not arbitrary. So there you have it. We have the z-score negative 0.37, and I guess the obvious question at this point is part E. Well, what does that mean? Okay, so we have this number, and this is very important as far as theory goes. We're going to be depending so much on z-scores in the future that I do believe it's very important that we understand what they are right now, which is why I introduced them a few weeks before we really start using them a lot. So remember that the z-score is basically a way of measuring, on average, how far away you are from the mean, okay, based on the standard deviation. So a z-score of negative 0.37 means that the salary of 110 is 0.37 standard deviations away. I should use a better word than away. Below the mean salary of. There. So Z-score is normalized data. So they take into account what the standard deviation is and what the mean is, and they take one score and they normalize it and tell you whether or not that score is a certain number of standard deviations above or below the mean. So in this case, because we're negative, that just simply means we're below the mean salary, and 0.37 standard deviations below the mean is how far below the mean we are. Okay? This next question is following that 68, 95, 99 rule that we went over in the notes. So this one here, at 99.73% of the population measures within how many standard deviations of the mean? Well, each level is one standard deviation more from the mean. So 68 is one standard deviation from the mean, 95 is 2, 99 is 3. So, boom, there you have it. Next question. An airline company is on average late 10 minutes for arrival. So that's going to be my X bar right there. If the variance lateness statistic is 9, so remember variance is the standard deviation squared, then what's the coefficient of variation? Well, we very briefly cover this correlation coefficient, which is on your formula sheet at the end of the notes. So it's just the standard deviation divided by the mean. So because we have the variance, we're just going to take the square root of it to get the standard deviation, and then we're going to divide by the mean of 10. Now when you plug that in on your calculator, which I will do right now, you're going to get 0.3. Now you need to multiply this by 100 to get the actual percentage, so 30% would be the answer. Another Z-score question, pretty straightforward. All the info is given. So now we have a test score of 142 here, and the mean is 100. So the mean is 100. The standard deviation is 15. And this is the score, so this is going to be the X that we're going to use. Now, it doesn't say anything about whether it's a sample or not, so I should have probably used mu for the mean, because remember, this is the formula. There we go. So the score that we're looking at is an IQ score of 142, and the population mean is 100, and the standard deviation is 15. So when you plug this in on your calculator, you will have an answer, or a Z-score, of 2.8. And we can see it right there, 2.8. So remember, this means you're 2.8 standard deviations above the mean. Well, let's try to look at your answer and see if it makes sense, right? Like 142 is bigger than 100, so it makes sense that at least it's positive. All right, this question. So a consulting company interviews 10 employees on how many minutes they work in a day. They find the average is 413 with a standard deviation of 26.8 minutes in a normal distribution. Now, it's very important that they say normal distribution here, because now they're asking us, what is the interval for the minutes per day worked that 68.26% of employees fall? Well, if it's a normal distribution, then we know it's going to follow that 68, 95, 99 rule. Okay, now if you're at 68%, that means that you are plus or minus one standard deviation within the mean. So we need to find that range. The average, or mean, is 413, and the standard deviation is 26.8. So if I want to find that 68% interval, all I need to compute is this. So I'm going to take 413 and I'm going to add 26.8 to it. That'll give me the upper end. And for that one, I get 439.8. And then to get the lower end, I'm going to take that mean and I'm going to subtract 26.8. So 413 minus 26.8, 386.8. 0.2. Now normally we write our answers when it's arranged using the square brackets, and we write the smaller number first, and then comma, and then the bigger number last. So this would be the answer. If you're doing this on your own, always check the bottom. Down here I have the answer flipped upside down. So if you print these off, then you can flip your paper and check. I don't plan on doing every single one of these questions every time that I release these, although I will do my best. Okay, now we have this question here, and we already did a very similar one before near the beginning. The only difference is they're asking for the variance. So you can look at your formula sheet for the variance formula. It's going to be identical to the one for standard deviation, just it doesn't have the square root in it. And I have included the answers down here upside down. So if you have any questions about this, you can email me. And that's the end of these extra questions. I hope you enjoyed. See you next time. Bye-bye.